So in this section, we're going to talk about the different types of reactions. So first up, we have synthesis reactions, we have decomposition, combustion, single displacement, double displacement, and redox. Okay, so 6 different types, and we're going to go through each of them here. So first up, we have synthesis reactions. So these reactions involve combining 2 elements to create one compound. So generally it looks like this, where you have element A and element B, and they combine to form compound AB. So an example is the formation of sodium chloride. So you have 2 sodiums and a Cl2 molecule, and they combine to form 2 sodium chloride molecules. Next up, we have decomposition reactions. So these are basically the exact opposite of synthesis reactions. You're going to have a single substance, a compound, broken down into the individual elements. So where we started with A plus B and got AB during the synthesis reactions, now we're starting with our compound. So we have our compound AB, and we're splitting it into A plus B. So an example would be splitting water molecules. So you have 2 water molecules here. You're going to split them, and you get 2 hydrogen molecules and an oxygen out of it. Okay, so we've split it into the individual elements. We started with a compound this time, and now we get out elements. Next up, we have a combustion reaction. So these ones I've always found kind of fun. They are reactions of burning things, but combustion reactions will involve some type of a combustible material, usually an organic compound, which means just that it has carbon in it, and that will react with oxygen. Okay? You will also get carbon dioxide and water in the products. You might have something else depending on what your combustible material contains, but generally you will always have carbon dioxide and water in the products and oxygen in the reactants. So it'll look something like this. This is the combustion reaction for methane, where you have CH4 methane, you're adding in oxygen, okay, so that's one of your reactants, and then you're getting out carbon dioxide and water as your products. Next up, we have single displacement reactions. So in single displacement reactions, basically it's going to be a single element on its own. It's going to replace another element that is contained in a compound. So it's kind of like at a school dance, if there's a couple dancing and then somebody comes up and boots one of them out and then takes over. Okay, so here we have AX and BX are our compounds. So AX plus B, okay, then you're going to have a single displacement reaction. So the B element is going to come in and kick out the A and take its place. So then you get BX as your compound plus A. So an example would be here. We have 3CuCl2, okay, and then 2 aluminums. So the aluminum is going to come in and kick the copper out and take its place. So then you get aluminum chloride. And then you have copper sitting out there on its own at the end. Next up, we have double displacement. So these are almost identical to single displacements, except you're going to see both cations switch partner anions. So you're going to have 2 compounds come in, and they both switch partners. Okay, so here we have AX plus BY, and then you're going to switch the locations of A and B. So now it's BX plus AY. Example, here we have lead nitrate and the potassium chromate. Okay, and then we're going to switch and get lead chromate and potassium nitrate. Right, so you can see basically you just switch your cations. Okay, so PB moves over and boots the potassium out, which then goes over and jumps in with the nitrate. Alright, so now we have redox reactions. These are the ones that are a lot more difficult to spot. Redox is short for reduction oxidation. Okay, so redox reactions involve chemical reactions where not only the atoms change places, but the electrons do as well, which is why they're a little bit harder to spot. Okay, so the charge on some of the individual atoms will change. So you have reduction is when atoms gain electrons. Now remember, electrons have a negative charge, so when an atom gains an electron, it's reducing its charge. It's becoming more negative. And then oxidation is the opposite. So oxidation is when atoms lose electrons, so they're getting a more positive charge. All right, so this is an example of a redox reaction. Oftentimes these are also single displacement. So if you have an option of going for either, pick either one, really, because this is also a single displacement reaction. Okay, so like I said, they're not as easy to spot. You actually have to look at the charges on each atom. So if you remember when we were looking at the naming compounds using the Roman numerals and the transition metals, we're going to do that same kind of thing here. Okay, so you're going to look at the charges on each atom. So oxygen always has a -2 charge. Okay, you have one oxygen in CuO and then one copper. So the copper has to have a +2 charge. The magnesium, as it's on its own, is already neutral. So it has a 0 charge. Okay, and then if you look at the products, now the copper is on its own. So it has the 0 charge. And then the oxygen again still has a -2. And the magnesium now has a +2 charge. Okay, so you can see oxygen kept its charge from the reactants to the products. It was always a -2. But copper went from +2 to 0. And magnesium went from 0 to +2. Okay, so you can see copper and magnesium have changed charges. So reduction is when it gains electrons. That's pointing at the wrong thing. Give me a second, let me fix that. Okay, so here you can see the copper has gone from a positive charge to a neutral charge. So it's actually gone down in charge, which means that it's gaining electrons. It's becoming a more negative charge. So it is going through reduction. And then on the flip side, magnesium is actually losing electrons. So it's becoming more positive. So it's oxidation. Okay, now reduction, gaining electrons, oxidation, losing reactions, there's of course a phrase to help you remember it. There are actually 2 of them. So either one works for this. The one that I've always used is Leo says Ger. Okay, so Leo is loses electrons, oxidized. Okay, so we can see that is actually what happened with the magnesium here. And then Ger is gains electrons, reduced. So that's what took place with the copper here. Okay, and then you also could use oil rig if you'd like. Oxidation is loss, reduction is gain. Okay, so either way helps you remember which is which. Again, I like Leo says Ger. Leo, the lion, means I get to use Mufasa. Yeah, anyway, Disney joke. Okay, so redox reactions. Which element is reduced and which is oxidized? So again, you have to break down the charges that you find on each element. Okay, so if it's on its own, it's a 0. Okay, now if you remember from the last chapter when we were looking at the charges on the ions, okay, each chlorine has a -1 charge. Okay, so you have 1 chlorine, 1 hydrogen, so that hydrogen has to have a +1 charge. Now, we move over to the chlorines. Okay, we have each one still has a -1 charge, but now we have 2 of them. Okay, so in order to balance that, your zinc has to have a +2 charge. Okay, now the hydrogen, it's 1 element. Okay, so even though there are 2 hydrogens, the charge is 0. Okay, all right, so now we look. We have zinc has changed charge, and our hydrogen has changed charge. Okay, so our zinc got more positive, right? So it lost electrons. It lost those negative charges. So zinc lost electrons, okay? Leo loses electrons, oxidized. So this one, zinc is oxidized. Okay? And then if we look at our hydrogen, right? Hydrogen went from +1 to 0. Okay, so it got more negative. So Ger gains electrons reduced. So this one is reduced. Okay? All right, so this is just going through it again. We've got our reactants. Zinc has a 0 charge, hydrogen has a +1, and chlorine has a -1. And then our products, okay, zinc has a +2, hydrogen has a 0, and chlorine has a -1. Okay, so this is easy to see. Zinc changed charge. It went up in charge, so it lost electrons. Hydrogen went down, so it lost charge but gained electrons. Okay, so hydrogen is reduced and zinc is oxidized. And that is it for this section.